to the fourth project of my grade 11 year, the Breadboard ATmega328P. This project is composed of two parts: the Breadboard ATmega and the digital dice. Here's how the ATmega328P Breadboard edition works. Here and here we have the power and ground voltages, here and here as well. However, for the analog to digital converter to work, this one right here has to be tied to some sort of reference voltage. Right now I have it set to 5 volts. While the ATmega does have an internal clock, it does require another one to go any faster. That's why I have a 16 MHz crystal right here with 2 capacitors for safety. This would normally be the reset button. However, due to the lack of space on the breadboard, I had to resort to having this be the randomizer button. In order to program this, SDK, MOSI, and MISO must be used as an ICSP. The ICSP would normally be attached here. However, I have lost that board, or someone else has accidentally taken it. So, I used an Arduino to program this. It would reside here. Here's how the digital dice system works. Here we have the 2 dice. A shift register outputs a random number map, either from 1 to 6. It's pre-programmed in the ATmega. All the positive leads from each one are tied together. This LED is tied to this LED, this one to this one, so on and so forth. All the negatives of each dice are tied together. Therefore, if these were both tied to ground, it technically would display the same thing. However, if I get 2 different numbers by pressing this button, I get 3, 4. It would be a mix of 3, 4 if they're both tied together. Since they're not, and I'm using a POV system, when it's high, it displays this one. When it's low, it displays this dice. It switches back so fast, as seen in the POV word, that it appears to be 2 separate numbers.